Yeah, this already we discussed. No? Okay, this is about the E bar wave. This is the unpolarized EM wave. This is what actually the antenna will generate to make students to have very good simple imagination. We have in the books we have shown. Nobody will generate this. It has to be modified using polarides. I will convert into linearly polarized EM wave. So definitely in exam they will test it because every book has given this one only. So you think that okay, the EM wave generator antenna or that one will generate. No, every equipment will generate this one only. By using polarization, I'll convert into the above diagram. So E bar and B bar will be rotating. So what is the diagram of this unpolarized? E bar will be rotating in a YZ plane. This is the thing. And they will propagate and also they vary with the time. They propagate along x-axis and vary with the time. Everything, all three will occur. So in polarization, we'll focus in detail. So there's a basic idea of that EM wave generated. Okay, now I'm interested in this as we know electrostatics. In a region where there's electric field, there must be energy. Come for like this, there's a E bar, no? In a region where there's a magnetic field, there must be energy. So I'm interested now the energy of EM wave. Got this? I think there's a basic thing that one. So we'll go for the energy of an EM wave. What we know energy density formula, no? So I'm deriving an expression for intensity of an EM wave. What is this EM wave made up of? A varying electric and magnetic fields. So energy density UE is what? The total energy density UD, I'll write it. Should be equal to sum of energy density due to electric field and the magnetic field. What is energy density due to electric field of epsilon naught E square plus magnetic energy density B square by 2 mu naught. But we know some basic idea. What is that like? What are these waves? They are varying sinusoidally, you know. So whenever if a quantity varies harmonically, we express RMS values. So the same energy density is expressed as RMS values here. I think, yeah, let it be this one. So what is ERMS? E naught by root 2. What is BRMS? B naught by root 2. Substituting that, the energy density will be half epsilon naught E naught by root 2 whole square epsilon naught E naught square by 4 . Okay, let's go back. Yesterday we brought some very historical things, no, like B naught C is equal to E naught, and C is equal to 1 by root of mu naught epsilon naught. This is from wave equation. This is what we derived. From where this C equal to 1 by root of mu epsilon from wave equation, because it satisfies the wave equation. So what is the speed of the EM wave given by this particular formula? In free space it is. This is. In any medium, we give expression. So let's try to replace. So let's take help of the mathematics involved. So what is the energy density of epsilon naught? Let me equate, let me see that what proportion these two energies are. Okay, this shall I equate? No, what is E naught? E naught should be B naught C. So epsilon naught B naught whole square by 4. So C square. So what is C square? You can write it as 1 by mu epsilon naught. So it is what it is equal to. Energy density of magnetic field only. So therefore, when an EM wave propagates, what proportion in these two will be equal? No? How much of electric field energy is there, that much of magnetic field energy will be there. So finally, I ended this one. And what is the magnetic energy density formula? B naught square by 4 mu naught. So therefore, so what shall I write here? So in an EM wave, what is the proportion? Both will be in equal proportion. In an EM wave, the magnetic and electric field energy will be in equal proportion. Both will be in equal proportion. That's what we are concluding. So therefore, this final equation, what we can write, energy density is equal to half epsilon naught E naught square by 4. Shall we write in terms of electric energy density only? Total, this should be equal to epsilon naught E naught square by 4. Okay, this is a total electric energy density, or so total energy density of EM wave. No, usually what happens, what to be known, either if you are writing in terms of E naught, okay. Let me write, and we know E naught is equal to ERMS, these ideas, I'll write it separately. So energy density is equal to epsilon naught to, what is E naught? We can write it as just equal to only this much, no? Or in terms of magnetic energy density. This can be also write in other way. B naught square by 2 mu naught. And what is B naught is equal to? Either of the form, the energy density of an
ARMS square.
square term missing. Okay, yeah, fine, thank you. Okay, this I think you have to remember. Either you can express in terms of ERMS or BRMS. Usually we prefer ERMS. Why like that? Because to detect magnetic field, the equipment's need is of large size, even till date. The detectors which will detect magnetic field, what happen, the equipments, what happen to detect magnetic field, direction, everything, no? You might have seen this in terrestrial magnetism. To find out B on a Earth, tell me what all we did. First, you should calculate BH. And for BH, what happened? Vibration magnetometer to calculate dip. Then a dip circle. Getting the idea. Then declination, for that freely suspended magnet. 3 equipments, you see that one. To measure the B of a Earth at a given point, we need 3 equipments. The same thing happens with even the EM wave. To detect that EM wave, if you take the B bar of an EM wave, the equipment will be large in size. How much of large means it may go up to the room size. You need a optical, you need a microwave bench. It's called like a microwave bench, that one. You need like equipment which is filled up in a room. That's why open. The E bar of an EM wave is more easier to measure than B bar. We can measure B bar, but the equipments are costlier and large in size. Very difficult to carry them, implement there, use them. E bar very easy. Okay, that's the primary reason. That's why in the maximum books, no, they didn't even, some books, they didn't bother to express energy density in terms of this. Nothing wrong, because keeping practical things in mind, this is preferred, no? So therefore they express only in terms of this. Okay, I agree this one. So the energy density either you can express in this or this. So we'll put it therefore. Okay, this is about energy density. How much of energy is present in a volume? How much of energy is present in a given volume? Because I have to go for intensity idea. So let this be delta A, area of cross section. Let this be length L. What is the length L? The wave will propagate in this direction. So what is this length L should be equal to, shall we write C into delta T? It will take some interval of time to propagate through this region. So here EM wave is present. So what is the energy? How we put it here, like, average energy density to volume. This is, I think, average, no? Am I right? Already we discussed in wave propagation. This is the average energy density. So what is the total energy, average energy? So this average energy should be equal to average energy density into volume of this cylinder. Average energy density. So let me take ERMS. So epsilon naught ERMS square. Okay, this is equal to what is the length of the cylinder? L into delta A. Or further, this is epsilon naught ERMS square. What is L? C delta T. And how we define intensity? Energy flowing normally per unit area per unit time. Energy flowing normally per unit area so that energy will flow here. I should not show direction for energy just for our understanding purpose. There is a direction of flow. So therefore, what is the expression for intensity? Energy bar per unit area per unit time. So this everything will become epsilon naught ERMS square C delta T delta A. So if you are bringing ERMS in terms of E naught, the same expression for intensity. Epsilon naught and E naught, please be alert. Or if you are expressing in terms of C B naught square by 2 mu naught. This is the expression for intensity of EM wave. Okay, I agree this. So there's a one either E naught or B naught, what is available, take help of that and you can predict here. Now, will it carry any momentum? Yes, the radiation momentum it will have. So what is the momentum? Energy by total energy by the speed of light. So and so like a momentum, it will carry momentum, or h by lambda, like they predict here, the momentum. Since it's a wave, no, so we don't go for momentum. If it's a photon, we define the momentum. Since we are talking about the wave, we are not bothered anything about photons. So like how many photons? Okay, let's not discuss, because we are discussing the wave nature of your EM wave. I agree this. So now will it, if this particular wave incident any surface, will it exert any force? Yes, then from that we'll get the radiation pressure. And that should be equal to what? Intensity. If it is high by C, complete absorption. And what is the radiation pressure if it's reflected? So they may test you with these things, this EM wave when it is incident, no? So I is what? The intensity. So what is the pressure, radiation pressure? So that radiation pressure is what? Force per unit area. So like that you can calculate the force exerted by the incident EM wave. Okay, this is about the basic thing. And if you look at the light is an EM wave only. And the electric field of a electromagnetic wave is responsible for its optical effect. I think I'll just put some